Hello everyone. In this series of deep learning, we are essentially going to learn about sequence models like recurrent neural networks, LSTMs and GRUs. First, we'll try to understand the different types of input data that we have considered while building multi-layer perceptron model and CNN model. So while creating multi-layer perceptron or feed-forward neural network model, we always have considered structured data. In case of CNN model, we have considered set of images. We just process those images and fed forward to convolution layers and then followed by dense layers and then output layers. So this is the overall architecture of CNN model. But what if your input data is no longer structured or image data, but rather it is sequential in nature? So one of the prominent examples for sequential data is stock price. So the historical price of a stock is a very good example for sequential data. And musical notes or music notes also is one of the examples for sequential data. We can also find speech, that is a waveform data. A person explaining about a specific topic basically has got some sequence associated with the dialogue, isn't it? So the sequence or the sequence of words that are part of the audio waveform data does have some context or meaning associated with it. So these are good examples for sequential data, or probably reviews as well, right? If you go to IMDb website, you'll have hundreds and thousands of different movies, and for every movie, you'll have dozens of reviews provided by different users. A particular review provided by a person has got a certain sequence of words which bear certain meaning to it. If the words are jumbled, the meaning is completely altered, or sometimes it doesn't make any sense at all, right? So the sequential information is very critical, and we need to preserve the order in which the words are provided within a particular review in the context of the reviews data that I'm talking about. All of this input data can be considered to be sequential in nature, and sequence models like recurrent neural networks and LSTMs are more appropriate for sequential data. The input to this particular model, to sequence model, or the output should be sequential in nature. It's not necessary that input should always be sequential in nature. Let's say that there is a particular image and you are trying to do image captioning. So in order to do image captioning, your input data is a particular image, right? So the output is a sequence of words. So here in this particular example that we are talking about, we have an output sequence, right? So sequence models is also being built for image captioning. If you look at this applications of sequential models that I have provided here, image captioning is one of them. So there are various applications for sequence models. So I have listed few prominent applications, but not all of them here. So within NLP, we have next word prediction. So next word prediction is one of the most popular tasks or popular language model tasks that we are encountering nowadays. Even large language models are more effective nowadays to predict the next word. So GPT models are nothing but predicting the next word, isn't it? So sequence models like RNN and LSTM basically are also used for text generation or predicting a given next word. Some might argue stating that why do we need to build sequential models in order to do next word prediction, but rather we can use a simple n-gram model. So there are certain downsides to using n-gram models. So n-gram, n here refers to the number of tokens that are associated. It could also be like bigram model or trigram model, right? So in bigram models, you will have two different tokens associated with each other. In trigram, you'll have three of them. Let's say that we are considering bigram model. At a time, we are considering pair of words like today, comma, is, right? So these are pair of words, and we have another pair like is, Sunday. So likewise, within your complete corpus, there could be pairs of different sequential words, right? So today and is follow a particular sequence. Is and Sunday again follow a particular sequence. So what we are exactly trying to do for next word prediction is like, let's say that this is a particular sentence that we are looking at. Today is blank, and it will search through all the pairs of words that you are having within your complete corpus and tries to find the probability of the next word, right? The number of times this is Sunday is occurring within your complete corpus divided by total number of pairs will give us a probability that Sunday is going to occur in this particular blank. Likewise, it tries to evaluate various other words and assigns a probability to each one of these words and rank orders these different words in descending order. Which one is the top? That is going to be the next best word that can be filled in this particular blank. So that's how n-gram models work. But if you are closely observing in n-gram models, the context window is fixed. Let's say that you are looking at the trigram model here. Sorry about that. Let's say that you are looking at the trigram model here, wherein you have three different words, which is today is Sunday. Now, in these three different words that you are having, the context window is defined as fixed in nature. Here, there are only two words prior to this particular target word. If you are considering Sunday as target word, there are only two words prior to Sunday which you are trying to evaluate. But you're not bothering about n different words that were prior to today, right? The complete meaning could be changed. Let's consider this particular example, like the temperature outside is very low. Temperature outside is very low. The weather is blank. Is it going to be cold or hot? We do not know that. Or sunny. We do not actually know if you are looking at trigram model. In case of trigram model, you're only considering weather, comma, is and a given word, right? So you're not worried about all of these words that occur prior to the weather is, right? The context window is very definitive and very minimal in case of n-gram model, wherein the complete meaning or the long-term dependencies is not catered to. So in order to cater to the long-term dependencies for a specific target word, then we are supposed to look at using these models like RNN and LSTM, right? So that's when sequence models are going to really help us. So apart from next word prediction, we also have text generation, like I've mentioned to you a while ago, which will help us in summarizing a bunch of documents that you're having. And it can also be used in sentiment analysis, like the movie example that I have provided, the IMDb review dataset that I have provided, the example that I have provided, basically comprises of different reviews provided by different users for hundreds of movies. And obviously, you need to consider the text data for every particular review and categorize it, whether that's having a positive polarity or negative polarity, that's positive sentiment or negative sentiment. So in fact, we'll consider that particular problem and try and solve the sentiment analysis by using any one of these models or both of these models. So we'll begin with that particular real world use case and later look at probably implementing text generation as well. Okay. And we also have named entity recognition. Like there are specific sentences where you might need to tag what are the nouns or probably what are the names of the individuals or what are the places that are provided within the given text and all. So named entity recognition is one such application which will help us tag all of those. Again, time series analysis, like I have mentioned, stock price prediction, because the historical stock price for a particular company is always sequential in nature. And models like LSTM generally are proven to be more effective and appropriate for such use cases. So image processing, image captioning is again one of them. And music generation and gesture recognition are again different applications. So I have not listed all the applications that are possible by sequence models, but only have listed few prominent ones. Okay. So why do we need to use sequential data? Why can't we use our generic feed forward neural network? So let's say that this is a feed forward neural network that we are considering. And obviously, the number of neurons in your output layer is fixed in your MLP architecture. So the number of neurons in your output layer is always fixed. But the output sequence is not always fixed, because let's say that you are looking at language translation. You are considering language translation as one of the problems here, wherein you are trying to translate from English to French. English to French. So today is Sunday. or probably the weather outside is very cold, whatever it is, right? The weather outside is cold. And there are in total about 5 different words in English for this particular sentence. And it's not necessary that you'll find only 5 words in French, right? So the number of words in French could be entirely different to convey the same meaning. Or when you translate this particular statement into French, it's not necessary that you'll always end up with 5 words. It doesn't go that way. And even you do not know the number of neurons in the output. The number of neurons here in language translation example entirely depends on number of words that are generated from it, right? So likewise, you also do not know the captioning that you would provide for a particular image. So if you are trying to solve this image captioning problem, there are various images. Sometimes you need to explain an image in 10 different words. Sometimes you need to explain it in only 3 different words, so on and so forth. Then also you cannot have the fixed number of neurons, which is one of the most critical steps in MLP, right? In MLP, you always find fixed number of neurons in your output layer. So fixed input and output size is not possible in case of sequential modeling problems. So no understanding of sequence order. So if you are considering X naught as one word or whatever it is. So let's say that there is one particular review that you are providing as an input, then obviously every input here in your MLP is independent of each other. So MLP, the multi-layer perceptron, assumes that every input is independent of each other. Every feature is independent of each other. That's what the assumption is. But in sequential data, every word is dependent of previous words. So that's another problem. And it's going to be computationally intensive when you are basically considering MLP, because there will be too many number of neurons that you might end up with for your input and output layers. And obviously it's not practical enough for the reasons that we have already discussed, for 1 and 2 reasons that we already have discussed. And this point number 4 is the parameters are not shared. If you remember properly, in MLP model, we did not share the parameters at all in the model training process. When it came to CNNs, so we in fact have shared the model parameters, especially the kernel values, are being shared across different localized regions within a given image. So that's what we have learned. Parameter sharing is one of the most critical ideas behind convolutional neural nets. So even for RNNs and LSTMs, you have this parameter sharing. Okay. So in MLP, we do not have parameter sharing at all. So if you're not having parameter sharing, it's going to be very much computationally intensive. The cost complexity of the overall model training process also increases drastically. Yeah. So we pretty much have tried to understand what sequential data is. We looked at the examples of sequential data, different applications of sequential models, and we also have learned why we cannot use feed-forward neural network there. Okay. In the next session, we are essentially going to understand in a greater detail on how we are going to alter our existing feed-forward neural network, like by introducing an additional embedding layer and also by introducing an additional RNN layer in case of recurrent neural network. Of course, we'll still retain the dense layer here. The dense layer is pretty much useful in helping us classify the given reviews if you are considering IMDb review dataset here. So we are in fact going to consider IMDb review dataset and try to solve the sentiment classification problem by using RNN model. Okay. And index based encoding and embedding matrix that is defined within embedding layer. So we have something called embedding matrix. So we have something called embedding matrix that we are going to define within our embedding layer, as well as index based encoding. So a conjunction of both index based encoding and embedding matrix is very critical for us to understand the sequence models better, right? So whatever input data that we were having was text data. So we need to somehow represent them to be numerical data, right? So for that, we are trying to understand what index based encoding is and how index based encoding is going to help us play a role in generating the embeddings here. So embeddings will be then later used by these dense layers if there is no RNN layer in between. Okay. So that's pretty much all I wanted to discuss with you in this session. In the next session, we are going to discuss thoroughly about what index based encoding is and try and implement that in Python. Okay. Thanks for watching.